Okay, so now let's take a look at the periodic table. Now, for a lot of us, this is just going to be a review, but I still recommend watching this video because I'm sure there might be something you've forgotten, or maybe you'll learn something new. And I've included this because it is going to be very important for us to know throughout this course. A periodic table will be available on all the exams you take. So it's definitely going to be important to make sure we're really familiar with it and to make sure we know the different groups that we could be asked for. So let's get started. So you may have noticed that the periodic table actually organizes atoms in order of their atomic number, or Z. And we can see that because these numbers written are just their atomic number. So they're organized 1, 2, 3, 4, 5, 6. So it's the Z is increasing from left to right, and then a new period starts. Okay, so periods are listed going are left to right. So they are rows. So these are periods. Okay, and as the period number increases, so as we go from 1 to 2 to 3, for example, the shells are actually increasing. So in the atom, n is equal to 1 might be here, one shell, and then the second shell is going to be here, it gets larger, at the third shell, and so on. So this is also referring to shells. So in being in period 1, it means that that atom only has one shell of electrons, two shells of electrons. Being in period 3 means you have three shells of electrons, and so on. Okay, now what about groups? So groups are really important also because they tell us about reactivity, and groups are the columns in the periodic table. So what I mean by they tell us about reactivity is that elements that are in the same group are going to have a similar reactivity. Okay, another interesting thing about groups is that if we look at the last digit of the group number, for our purposes, will tell us the valence electrons. So for example, 2 means that anything in this group has 2 valence electrons. Or 15, we look at the last digit, anything in this group has 5 valence electrons. Or group 17, anything in this group will have 7 valence electrons. And that is very important because it helps us understand why each group reacts the way they do. And it makes sense that they have similar reactivity since they have the same number of valence electrons in a group. Okay, so now let's go through the naming of the different groups so you can know the names in case that comes up on your exam. So if we start from the very left, we have the alkali metals. And there's one exception to this group, and that's hydrogen. So hydrogen is not an alkali metal, so you can tell there's a difference in color there for a reason. Hydrogen is not an alkali metal, but the reason why it is in this group is just because it has one valence electron like the other alkali metals. So don't get confused there. Hydrogen isn't a metal, it's a gas, we know that. And so the rest of these are alkali metals, okay? So this group 1 in the periodic table, are alkali metals. And these metals are extremely reactive, okay? Okay, and we'll talk more about why that is in just a second. The next group are also metals, and they are called alkaline earth metals. They're not as reactive as the alkali metals. Then next we have this kind of indented part of the periodic table. This little box kind of. And that we call all of those atoms that fall in that box transition metals. And they are also not as reactive as the other metals. Okay? Then another group that is of importance is this nitrogen group. So it starts with nitrogen. You may also see this group be called pnictogens. We also have this oxygen group that sometimes is referred to as chalcogen group. Okay? The next really important group to know are the halogens. Okay, now the halogens are also quite reactive, and we'll talk about that in just a second. So this group is the halogens, and the last group on the right are our noble gases. Okay, there's actually one more group on the bottom where it starts actually from here in this spot. You read from here, so you'll see 57 to 71, and then it continues, and then from this spot you go down to 89, and then it continues 103, and it goes to 104. But these are really not tested on in first year chemistry, but we can still go over the naming. So this first row are called the lanthanides, the second row are called the actinides. Collectively, we can refer to them as the rare earth metals. The next thing I want to discuss is where can you generally find metals on the periodic table versus non-metals and something called metalloids. So in general, does it look like the metals are on the left or right side of the periodic table? So in general, we already labeled alkali metals, alkaline earth metals, transition metals. So metals are definitely found on the left side of the periodic table. So then it makes sense that the non-metals are generally found on the right side of the periodic table. Okay, and what separates the metals from the non-metals is a metalloid staircase. So it's this imaginary staircase that we can draw in the periodic table. And anything that touches this staircase is a metalloid. And a metalloid is just something that it shares properties of both metals and non-metals. Now notice that they are all colored in this color, but on your exam you're not going to see this nice colorful periodic table. So what I want you to remember is that aluminum is a bit of an exception. It touches the staircase, so you might think it's a metalloid, but it's not. Aluminum is a metal. It's not a metalloid. But everything else that touches the staircase is a metalloid. And you can just remember that because aluminum is a solid, so that'll help you remember that it's a metal. Okay, so now how are metals in general different from nonmetals? We mentioned earlier that alkali metals are extremely reactive. Okay, so you can imagine nonmetals are going to be opposite. They're not going to be as reactive. And another difference is that metals in general can conduct electricity, whereas nonmetals do not conduct electricity. Another difference is the way that they look. So metals can be very shiny. So if we think about gold down here, gold, we think, it's very shiny. It's a really nice metal. Whereas non-metals are not shiny. So we think of more things like gases. So we have nitrogen gas, oxygen gas, chlorine gas, a lot more things like that instead. Okay, and the last thing I want to touch on is reactivity. So we mentioned that alkali metals are extremely reactive, okay? And the reason for that is because they only have one valence electron. So they really, really want to lose that one valence electron so they can have the electron configuration of a noble gas, okay? And something that's very unique about the noble gases is that they all have a full octet. So notice that they all have 8 valence electrons. So that means that they're going to have a full octet. They're going to be very happy, very stable. And they also are sometimes called inert gases for that reason. Inert just means that they are non-reactive. They don't want to react at all because they're very happy the way they are. Whereas for alkali metals, they have these crazy explosive reactions. They want to quickly react because they really want to get rid of their one valence electron to have the same electron configuration as a noble gas, or to have that full octet that a noble gas has. Another very reactive group are the halogens. And so they have 7 valence electrons we mentioned. Now for them, they really want to gain an electron to be more like the noble gases, or to have the same electron configuration as the noble gases. Right now they have 7 electrons, and ideally they want 8 like the noble gases so that they are also really stable. So you can imagine that since alkali metals really want to lose 1 electron to be like the noble gases, halogens really want to gain 1 electron to be like the noble gases. It's very common for alkali metals and halogens to react together. So just know in general that those are both very reactive groups. And also know that the noble gases are very unreactive. They're already happy and have a full octet. So now we've just reviewed the different groups in the periodic table, differences between metals, nonmetals, and metalloids, and all this information can come in handy on an exam. Down here is just a summary of the different labels that we went over. So you should also try labeling a periodic table or looking at the blank version in the notes and seeing if you can know where the alkaline earth metals are or the halogens are, noble gases, a lot of the main names. That would be really helpful for you for your exam.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.